Hello again. Continuing our problems from chapter 3.1, I'm going to do problem 50. This problem says, the directions say find the absolute maximum and absolute minimum values of f on the given interval. Thanks to the extreme value theorem, we know that if you have a continuous function, this is continuous, it's just a nice polynomial, on an interval, on a closed interval, then you are definitely going to have an absolute max and an absolute min. So you could graph this, and you could tell immediately off the graph which is the min, which is the max. Algebraically, you're going to have to show it algebraically. What do we do? Well, the first thing we do is let's get the derivative. Because if there's any local maximum or minimum values in there, that's going to be where the derivative is 0 or undefined. So we're going to get the derivative. We got to use the chain rule. Bring the 3 down, decrease the exponent by 1, multiply by the derivative of the inside. Okay? Now we don't want to multiply that out. Let's not do that. All we need to know is where is this undefined? It's defined everywhere on that interval, so we're okay. The other thing we need to know is where is this 0? So we have to solve this. Well, we want to keep it in factored form. As a matter of fact, I want to factor this too. T squared minus 4, that's the difference of two squares. So that's the same as t plus 2 times t minus 2. Now the square we apply to both terms, right? Because we're breaking up t squared minus 4, and then we're applying the square to both terms, and then we have 2t. Okay, where is this 0? It's where each factor is 0. Well, this factor is 0 at t equal to negative 2. This one is 0 at t equal to 2. And this one is 0 at t equal to 0. So now we know 3 places where we could have a max or a min. We could also hit a max or a min at the endpoints, as we saw in some of the graphs we were looking at. So what we have to do is make a table of values. So I want to look at where t is negative 2, where t is 0, where t is 2, and where t is 3. I want to make sure I look at the endpoints and all the critical values. And then I'm going to look at what the function value is at those places. If I put a negative 2 in here, negative 2 squared is going to be 4. 4 minus 4 is 0, so this is just going to be 0. The original function. If I put a 0 in, I'm going to have negative 4 cubed. So negative 4 cubed is going to be negative, let's see, 4 times 4 is 16. 4 times 16 is 64. So I'm going to get a negative 64. Put in a 2, well 2 squared is 4, minus 4 is 0, I'm going to get 0 again. Put in a 3, 3 squared is 9, minus 4 is 5, 5 cubed is 125, let's see, 5 squared is 25 times 5, times 25 times 5 would be 125. Okay, so where's my absolute maximum? The absolute maximum is 125 at t equal to 3. The absolute minimum is negative 64 at t equal to 0. So there we have the complete answer to the problem. So on any closed interval, you test the places where the derivative is 0 or undefined. You test them by putting those values for t into the original function. And then you also test the endpoints. So notice the maximum, the absolute maximum came in an endpoint. And the absolute minimum came here at 0, at a place where the derivative was 0. Now you can graph this and check yourself. You can graph this, take a calculator, graph this between -2 and 3, and see if that looks right. So even though I'm asking you to write this out algebraically to see what's going on without the calculator, you can use the calculator to check yourself. But remember, the answer isn't the point. The point is understanding the process. See you again soon.